lesson is dilating a line. And this lesson is similar to yesterday's lesson in terms of when we talked about a perpendicular bisector, we related constructions to writing the equation of a perpendicular bisector. So when we dilate a line, we're going to somehow tie in our knowledge of constructions dealing with the dilation. So if you think back to when we dilated segments or images, I should say pre-images, in class with the dilations, we talked about a couple of things. And the first thing is that anytime we deal with the dilation, there are two main components, a center of dilation and then the scale factor. So when you dilate something, it's becoming bigger or smaller. Moving away from the center or closer to the center. It could go on the opposite side of the center, so on and so forth. But in terms of a dilation with a line, it's a little different because a line goes on forever. So when we dilate a line, we're really not changing the size of the line. With a dilation, something that stays the same is the slope. So pre-image to image under dilation, they're always parallel because the slope stays the same. So that's going to help us with the dilation of a line. So remember, when we're dealing with lines, we're dealing with y equals mx plus b form, m being the slope, b representing the y-intercept. So here are just some key facts. We had said this before. Under dilation, we know slope always remains the same. So that means that the pre-image and the image must be parallel. That's key for dilating a line. Okay, so we're going to go through some things. So in order to write the equation of a line that's being dilated, we're going to run through some steps, and it's similar to when we did the directed segment, the different ratios, and finding the point that divides a segment into a specific ratio. We followed a series of steps. So the first thing is that the slope of the line that has been dilated must be the same. So if we're dilating something, if we can find the slope, we know that that slope has to be exactly the same because my image has to be parallel to the pre-image. So that's going to be key, identifying slope, because your slopes, like I said, must be the same. Okay, so slope is a key thing. Next, we're going to test the center. So what does that mean? Well, anytime you test a point in terms of an equation, you plug it into the equation. Remember, a point represents an x and a y value. In an equation, we have an x and a y value that we can substitute in for. And this is the important part. If the center falls on the line, so if that center that we tested here makes the left side and the right side equal, the equation is exactly the same. The equation doesn't change. And that's because if you dilate while the center is on the line, you keep on dilating on top of the line. The points that you make, the new points, keep on falling on the line. So therefore, the equation doesn't change. But if the right side doesn't equal the left side, so if the center is not on the line, then the y-intercept gets dilated by the scale factor. So remember, when we dilate something, that really means to multiply. So with all this kind of being said, it's a lot of, multiply here. It's a little slow, sorry. It's a lot of testing and just kind of following a series of steps. So what we have for this lesson is, this is basically it. This is the lesson in itself, 4 steps. Putting it all together and figuring out what is the question asking me is how we apply these steps. So let's take a look at an example and see how we do. Okay, so it says line N is represented by the equation 3x plus 4y equals 20. Determine and state the equation of line P, which is the image of line N, after dilation of a scale factor 1/3, centered at a point 4, 2. You can use the set of axes below, that's optional, and then explain your answer. Okay, so we're figuring out the equation of line P after dilation, scale factor 1/3, centered at the point 4, 2. So first thing is we have to figure out, does the point fall on the line? We have to test the center, as well as deal with the slope. We have to find the slope of our pre-image. Now, the interesting thing here is that this is an in y equals mx plus b form. And although it's really important to deal with the slope, it's just as important to test the center. Because here's the thing, if the center falls on the line, so if I take these values and plug it into this equation, and it winds up that the left side and the right side are equal, I could just rewrite this equation just as it is. So you kind of have some options in terms of following your steps. So if you take a look at what I did, I kind of did step 2 before step 1. And I said, all right, so if my center for 2 makes this equation true, makes the left side equal to the right side, I'm golden. And take a look. I plugged in x for y for 2. The left side equals 20, and then the right side equals 20. So since this happens, my equation is exactly the same. So I'm allowed to write the equation for 3x plus 4y equals 20. It doesn't say it has to be y equals mx plus b form. Then it also says to explain your answer. So how did I know that this was the equation? Well, since the center falls on the line, the equation stays the same. And that's exactly it. How did I know if the center falls on the line? The center made my equation true. The left side equals the right side. Over here, I just put the 3x plus 4y into y equals mx plus b form. You don't need to do that if it doesn't specify it. But this is kind of what I like to show you. And it's the equation y equals negative 3/4 x plus 5. So I went to my y-intercept at 5, down 3 into the right 4, and I kept on doing that. Now, think about this. This is going to kind of go back to using our compass in the beginning, or actually we did dilations a little bit later in the year. Just give me a second. I'm using the tool for one of the first times on here. Oopsies. All right, so let's see if I can switch this, get this here. So, scale factor is a third. Whatever the scale factor might be, think about it like this. No matter what the scale factor is, here's my center, and then I would have to draw through my rays. Think back to class when we would dilate. So no matter where I would go, no matter how big or small I would make it, it's moving along this ray. So my line, my points keep on falling on top of the same line, therefore my equation doesn't change. Okay, so that's this one. Okay, so example 2 is going to be a little different. Now I'm going to show you when the center of dilation doesn't fall on the line or the line segment. So how do we deal with that? And here it is. So it says a line whose equation is 3y plus 5x equals 12 is dilated with a center at the origin by a scale factor of 1/2. Write the equation of the line in slope-intercept form. Okay, so that's important, right? Slope-intercept form is y equals mx plus b. Here's the equation, centered at the origin, scale factor of 1/2. Okay, so here are steps. Slope is preserved, right? So I know that I first have to get this into y equals mx plus b form to find my slope. Then I'm going to test the center. Then I have an extra step to do. So I'm going to show you what I did first and kind of walk you through it. So first thing is I found my slope of negative 5/3, and I did that down here. I took my original equation, 3y plus 5x equals 12, and then I began solving for y. So I subtracted 5x, have my new equation, 3y equals negative 5x plus 12. In order to get y by itself, I have to divide by 3. So my new equation is y equals negative 5 over 3x plus 4. So here it is, bam, my slope. That slope has to stay the same. Second, I have to figure out, is the center on the line? So does the origin fall on my line? So to do that, I test the origin, 0, 0. So over here, here's my origin. Plug in 0 for x, 0 for y, and look what happens. 0 equals 12. That's not true, right? 0 doesn't equal 12. That means that the center is not on the line. So since the center is not on the line, but it's centered at the origin, I find my y-intercept of my new line by multiplying the y-intercept by the scale factor. Okay, so the scale factor is 1/2. My y-intercept is 4. So I do 4 times 1/2, which equals 2. So, oh look, I don't even have the new equation anywhere. My final answer is, what's the equation of the line? Well, here it is. We have y equals, let me switch this up so I have a pen or a crayon, something to write with. This is right, yep. So y equals, okay, my slope, here it is, -5/3 x, my y-intercept. Well, my y-intercept was multiplied by my scale factor to give me the new y-intercept of +2. And here's your final equation. There it is. Right? It's kind of how you mesh everything together when it's not, when the center doesn't fall on the line. Except just multiply your y-intercept by your scale factor. Keep the slope the same. All right, on the back, a couple more examples. Here's this one. Explain why dilating the line y equals 3x by a scale factor of 2 about the origin would not change its equation. Okay, so think about why this equation, y equals 3x, would not change if it's centered at the origin. Not going to change. All right, so only reason why something would not change would be because the center falls on the line. So we test and we say, okay, well, my center is 0, 0. Here's my line. Plug in 0 and 0. Left side equals right side. Here's my explanation. Since the center is on the line, the y-intercept doesn't change. The slope remains the same. Therefore, the line stays the same. The equation stays the same. Okay. All right, example number 4. Here we have it. It says the line whose equation is 3x minus 5 equals 3x minus 5y equals 4 is dilated by a scale factor of 5/3 centered at the origin. What statement is correct? All right, so this is a multiple choice, and here we have it. I'm just going to kind of go through and let's see. We see the right answer, but let's see why. So it says the image of the line has the same slope as the pre-image, but a different y-intercept. Okay, so I definitely like it should have the same slope. So anything that says anything about the same slope is good. Now 2 is not good because it says it has a different slope. Remember, if we're dilating a line, slope can't change. So 2 is out and so is 4 because they say different slope. We need the same slope. Okay? Now the difference between 1 and 3 is it says we have a different y-intercept and the same y-intercept. The y-intercept would be the same if the lines, if the center falls on the line. If we go up here, if you were to test the origin in here, so if I plugged in 0 and 0, I would get 0 minus 0, which is 0 equals 4. That's not true. That means that the y-intercept must change. It has to be different. So that's why it's choice 1. Center doesn't fall on the line. Therefore, my y-intercept would have to change. Okay, and I think I probably showed that work down here. Kind of gave you some notes. There they are. Okay. And then we have number 5. And number 5 says, the line represented by the equation 4y equals 3x plus 7 is transformed by a dilation centered at the origin again. Which linear equation could represent its image? Okay, so first thing is I put this into y equals mx plus b form. I took my equation, put in y equals mx plus b form. Here's my slope. The slope has to be 3/4. Okay, second thing, I tested my origin because that's my center. Plugged it in here, I saw that the left side and the right side are not equal. Therefore, that means that my equation, the y-intercept has to change. My equation can't be exactly the same. So I figured out, well, if this isn't true, right, I need to then figure out, well, what could possibly be my new y-intercept? Well, your new y-intercept, does it say? It doesn't say what the scale factor is. Okay, so I'm really just focusing on the same slope. So I took choice 1, and I have 3x minus 4y equals 9, and I started getting these all into y equals mx plus b form. So look over here at choice 1. I subtracted 3, and then I divided by -4, and I see that a -3 divided by -4 actually becomes +3 over +4. That's a good slope. Okay, but as soon as I did this over here and I started number 2, if I subtract 3, I get a -3, and then divide by +4, that gives me a negative slope. That wouldn't be good. This slope over here would give you a +4/3. We need 3/4. So basically you need to put them in y equals mx plus b form and just look for the slope that's 3/4. We don't have to worry about the y-intercept necessarily because they didn't give us information in terms of what the scale factor was. So that's how we know it has to be choice 1. Okay. All right, and then finally we have number 6, and it says a line segment is dilated by a scale factor of 2, centered at a point not on the line. Which statement regarding this relationship between the given line segment and its image is true? Okay, so line segment, dilated, scale factor of 2, but the center is not on the line. So we know that these lines should be parallel, therefore they should have the same slope, and they shouldn't have the same y-intercept. Right, so let's see what we have. Okay, so it says that the line segments are perpendicular. Nope, we don't want that. Line segments are perpendicular. Nope, don't want that. Okay. Line segments are parallel. Good. Line segments are parallel. Now, the scale factor is 2. So what's bigger, the image or the pre-image? Right, so what's bigger, the image or the pre-image? Well, the image is where I end up, and the scale factor is 2. So the image should be twice as big as my pre-image, or the given starting point. So let's see which one says that the image is bigger. And I think we have that. Oops. Right here, choice 3. The image is twice the length of the given line segment. Perfect. This says that the image is 1/2 the length. No, that's not true. So we have choice 3, and there it is. Okay. So this was really kind of a shorter lesson in terms of we're really just applying our knowledge of dilations. We went through a bunch of examples. They don't all deal with going through all 4 steps all the time. But you definitely have to focus on the fact that when we're dealing with dilations with a pre-image and an image, slope is always the same because the image and the pre-image always are parallel. Then we talk about testing the center. If the center falls on the line, that means that the line is exactly the same. The equation stays. So the y-intercept does not change. Neither does the slope. If the center is not on the line, but it's centered at the origin, well, yeah, the y-intercept must change. And it changes by multiplying that y-intercept by your scale factor. There is no additional assignment that you have to submit with this lesson, nor was there one for yesterday's lesson. Monday is going to be a review day in terms of you just kind of looking over your notes, maybe rewatching a couple of videos, and then you will have your Castle Learning quiz Tuesday and Wednesday of next week. It's going to be your final quiz of 4th marking quarter. So all multiple choice, you do get to retake one if you choose to retake it and get full credit back for anything that you then answer correctly. I will post another video Monday just reminding you to really take advantage of the fact that you can, while you're taking the quiz, jot down some good notes. If they go through the solution, you can jot down that solution. So when you retake the quiz, you can get the best grade possible. And again, that will be your final quiz for 4th quarter. And then the following week, you'll have a Google form. And that's kind of how we're going to end the year. So I hope that you enjoy your weekend and sign back on Monday, or you'll see a post on Monday for our Google Classroom, and I'll have a video. And again, I'll just kind of go through some quick review things in terms of the different topics to go over and just remind you about Castle Learning. Okay, everyone, take care.